very selective, and these sensors should be very selective, very affordable. Okay, so I don't know what did happen, but I was out of.
Sir, sorry for the technical glitch. Sir, please share again.
Okay. Okay, I'm back to business now.
Yes, please.
Yes. So to maintain a disease progression, it is very important that we must have some sensors which are very sensitive, means which can detect a biomarker at very low concentration. Second, they should be affordable. It should not be expensive if we are considering a disease management in India, where most of the people lives in rural. And at the same time, they should be very selective. They should detect only that particular marker, not other things which are not required. So these things can be achieved if we develop a biosensor based on the state-of-the-art technology, and these sensor can be developed against any diseases. So these are the projects I am working in my lab at that moment, and we can see the progress as I move forward in this presentation. And first thing first, biosensor is a very important branch of science and research. It means biosensor is an analytical device that deals with biological responses, and that responses can be converted into a signal, and that signal can be quantified. And this quantification can be correlated with the concentration of the marker that we are planning to detect. So suppose I can make this biosensing prototype based on selecting a very important material that we need to immobilize a biomolecule. The biomolecule that we immobilize on nanomaterial is against the disease to create a selectivity. For example, if I need to detect coronavirus infection, then my target molecule is coronavirus, which is SARS-CoV-2. And to select that molecule selectively, I need antibodies. So now I have a substrate that has nanomaterial. On top of that, I'm having antibodies. And these antibodies will detect virus in a real sample. That real sample can be saliva and can be urine and can be blood. It depends that which disease we are targeting. Most of the time we avoid blood because blood is very infectious and it's not easy to take out from a patient. So we always try to believe in non-invasive approaches. And in that case, saliva is the first choice of biomedical expert, and sometimes urine can be used for the sensing of a particular diseases. So I am also following the same concept in my lab and trying to making different biosensing prototype. So when I came to the United States, my first project was to make a sensor which can detect the cortisol. Cortisol is a very important biomarker which is present in our body, and this has a correlation with the psychological stress. And the challenge is that in the present lifestyle, we all have a lot of problems. we have psychological stress, and psychological stress is so important that nowadays doctor has to know the amount of cortisol before prescribing a treatment where brain diseases are involved. But there is no way they can quantify the psychological stress. So the question is that came from the US government in 2013, that can we quantify the psychological stress? Because it looks like American life is very good, but it's not. Imagine the kind of stress they do have in terms of making capital. Their police force, it's so equipped all the time. They have to have a lot of things with them. The firefighters, military, teachers, athletes. The major concern here is athletes who make $1 million per year, and their psychological stress is different. Farm firefighters, farm workers. So the question was from the government is, can we quantify the psychological stress? And the answer was yes. If we can quantify the cortisol at a very low concentration, then we can quantify the psychological stress. So this was my first project. Over there, I used interdigitated electrode to immobilize antibodies which can capture cortisol in saliva. So it was a systematic study. It involved a lot of electrical engineering, chemistry, and little bit surface science. I put the component together and I used cortisol antibodies to immobilize on interdigitated electrode. In the making of a sensor, it's very important that we characterize every step to confirm that our procedure is systematic and it is in the way it should be. So every time I do changes on the surface, I did electrochemical characterization, and with reference to the different interaction on the chip, I figured out that either electrical response is increasing or decreasing in terms of resistance and current. So every time I did experiment like 3-4 times, same measurement 3-4 times to see that whether my system is repeatable or not. After making step-by-step characterization, I was able to detect cortisol at 10 picomolar. That time in 2014, that was the lowest detection limit reported by our group. But the point is that having a sensing prototype is good, but it's not solving the purpose if we cannot take this device to the field. Stressed people generally feel more stressed when they are in the field, not at the home. Or if they are at cleaning, they might be calm, composed, but there's a possibility. Then they have to detect this stress at the site of function. So our objective was, can we make a sensor that look like a cell phone, or a couple of components, but can be operated by the cell phone? So in that case, many component appears, sampling. We needed to use saliva as a sample. And then to have the less error, we need automation of the real sample. So we used microfluidic system. And to measure electrochemical response, rather than we use 3 feet by 2 feet electrochemical analyzer, our student developed a customized potential state that looks like a PCB board that was interfaced with smartphone. And all together, we were able to make a very small cortisol sensing chip that detects cortisol perfectly from 10 picomolar to 10 micromolar. And this concentration is physiologically recommended. And also the cortisol we selected in this project was the free cortisol, which is related to the psychological stress directly. We tested these sensors against the sample we collected from the farm workers who supposed to expose with pesticide very often, and this pesticide inhalation increases their psychological stress. And another class which is very known to be stressed always is HIV patients. So all we know that HIV is also a very serious infection. If somebody got HIV infected, then I don't think there is a single medicine that can remove virus completely from the body. So HIV again does not have a complete treatment, but yes, HIV has a management system. So we also took the real sample of HIV patients and check their cortisol level. So my intention here was not to correlate the mental health of HIV patient with cortisol concentration. My intention was, let's take a sample, detect the cortisol using my sensor, and detect the same cortisol using commercially available sensing system like ELISA. So I see that my sensor and commercially available system gives the same value, or they are in agreement of 3 to 5% variation, which is completely acceptable. So, but the difference is that my sensor gave results in 40 minutes and the ELISA need a day. And ELISA is expensive. My sensor was not expensive. So once you are trained in a particular field, then you can use the same expertise to solve other big problems. From 2014 to 2012 to now 2014, I did the cortisol related project. Project was successful, and still my previous advisor is in the process to make a fully functional miniaturized cortisol detection system that can be used anywhere. So back in 2014, world was dealing with another problem, which was Zika virus infection that came from Brazil. And this Zika virus causes fever like Ebola and coronavirus does. But the seriousness of Zika virus protein was with reference to either newborn babies or unborn babies, because this virus transmits from mosquitoes to human. But if this virus is in a pregnant woman, then this virus can go to the brain of unborn child and create microcephaly. Microcephaly is a disorder in which the brain is underdeveloped. Imagine the child who born with small brain or not a functional brain. This is a disaster. So American government was very serious for that, and the state of Florida said that whoever can do something in this field are very much welcome. So we got a project from state to make an electrochemical system which can detect Zika virus protein at a very low concentration. So I used the same sensing principle for the Zika virus. Of course, when we are changing a disease model, then everything we have to optimize from the stage one. How much antibodies is binding, how much time we need to bind it 100%, how many days this can stays on the surface, how much virus it can detect, how many time it can detect. So I did systematic studies and systematic characterization and demonstrated that my sensor can also detect Zika virus protein from 10 picomolar to maybe 10 or 100 micromolar, which is very important concentration range physiologically. And also, this sensor can be used at clinical level to check whether an investigated treatment model is working or not. Because the treatment investigated for infectious diseases, they don't work in a day. They work slowly. And during this slow process, the virus concentration changes at a very low scale. This minor change even cannot be detected by ELISA, we need to do RT-PCR, which is again a very expensive and time-taking procedure. So to check the performance of a treatment, we need to often measure the concentration of a targeted virus. So in that case, sensors that I developed are very useful because they work fast within 30-40 minutes. They can detect low concentration and they can do real-time testing or real-time measurements. And the sensor I made for Zika virus was tested against the infections which were associated or which are associated with mosquitoes and also create the same type of fever like dengue, chikungunya, and others. So I observed that my sensor is selective. We have US patent on this research, and this research was published in a very good journal and also presented in a very good society. And the society gave me Young Investigator Award for this investigation. But device portion of this sensor is still in progress. We have a prototype, optimized prototype, an efficient prototype. Now we are converting this into the device. So once you're trained well, you can use the same skills to solve different problems. So now I know how to make a biosensor, biosensing chip to detect a biomolecule at very low concentration that can be used for efficient diagnostics and also can be used to check the performance of the drug in clinical practice. So by the time I completed this project, we started talking about coronavirus. And I think I don't need to talk more about this coronavirus. This is a very serious virus. It also causes fever, but it in fact, our respiratory system, mainly lung, in a very serious manner, that it makes our lungs very weak because this virus replicate in the body very fast, and to replicate in the body, it need an enzyme. And the enzyme that virus needs is found a lot in our nose. That's why through the nasal route, it progresses fast and deposit in our lung. And lung also has the same type of receptor a lot. So lung is the factory to produce coronavirus. And this coronavirus eats most of the oxygen of the lung, and the people got a respiratory problem. That's why this virus is deadly for the people who are having respiratory problem. So how we can manage that? The recommendations from the government was very simple. This virus transmits from human to human, so better make a distance from the humans. Protect yourself. Keep masking. Wash your hand. It's very nice, but these are very boring type of practices. People sometimes do, and as a human, we make mistake. So we have to rely on testing. Let's see how many people are infected. For that, we need different techniques to detect coronavirus selectively, and these techniques should not be mainly for clinical standard. It should be clinical standard, but not for the clinical level, because not everyone can go to the clinic. And so we need rapid testing systems which can detect coronavirus very selectively. And now the problem is the mutation in the coronavirus. So the good thing is that most of the sensing system we have in the market are based on the surface receptor protein of this virus. It is spike protein. So this spike protein binds with the receptor which are present in our body, and this virus spike protein can be used to detect it selectively. So a lot of research work in the field of making antibodies which are selective to this virus protein, or aptamers or DNA-based approach that can detect this virus selectively. And then these antibodies, aptamers, or DNA was used as a biomolecule recognizing element in the making of testing systems. So these testing systems were calorimetric, means they say yes or no. And other approach was quantitative estimation. In that approach, they always say, yes, this is the level of your virus. And based on this information, doctor prescribe the medicine. If the infection is low, no need to go for high dose of the drug. Another problem in this COVID management is excessive knowledge. People read a lot on internet and they become doctor by themselves and eat unnecessary stuff. That unnecessary stuff created a lot of problem in COVID patient people. Sometimes they were not having problem because of virus. They were having problem because they ate a lot of unnecessary stuff. So that is not the focus of my talk. And in my research, I was explaining the need of developing a coronavirus sensing prototype. At the same time, I also used my knowledge of making drug delivery system that can deliver a therapeutic element which can either capture the virus and at the same time neutralize the virus. But in the treatment of virus, there are two approaches. First, we have to identify that. Second, we have to remove this virus from our body. Third, the recovery from this infection is slow, and also someone got immunocompromised. It means the nutraceuticals, maybe the natural compounds should be the part of treatment. These natural compounds will help individuals like immune boosting system. So along with having vaccine or antiviral therapies or heavy drugs, steroid, every COVID patient must eat some nature-based compounds which helps in immune boosting process. So my thoughts on coronavirus in terms of sensing and exploring new drug delivery system was appreciated by WHO, and they put my research in their database. So now back to the sensing part. Nowadays, you will see that many government have their apps which are claiming to track the COVID patient. They make different system. Tracking of tasks, of tracking of patients were very, very important factor in the management of COVID. And I propose the same thing. If I have a sensor which can detect coronavirus in a very good amount that we're supposed to know, and this information, if can be shared by the hospital immediately, then we don't need to send experts to the field. Anyone can do testing and that value can go to the hospital, and over there, doctor can suggest the treatment. So the sharing of data became very important, and to make it more practically advanced and effective, we have to introduce new techniques along with the sensing strategy. One is artificial intelligence, which is a predictive approach. We can decide what to do, what not to do, and Internet of Things. Internet of Things is like hardware-based approach, which makes smartphone very smart. And idea is that let's make a sensor that can be operated by the smartphone, and the data we are collecting by the smartphone can be shared by the hospital based on data, based on cloud. Excuse me. And altogether, this will be an approach of telemedicine. I'm not the first one who is claiming like that. People are doing research in this field, and they are making their sensor more efficient with the help of artificial intelligence and Internet of Things. So in my lab, we are also making smart sensors for the detection of coronavirus. I would like to skip this because this development was with reference to Zika virus. Yes. in my lab, in collaboration, one of my collaborator, we use the same concept. First, we will work we will work on developing a sensor which can detect coronavirus at very low concentration. Then the same chip will be interfaced with a very miniaturized electrochemical analyzer. And altogether, this analyzer will be operated by a cell phone. And the detection data will go to the hospital using Dropbox, OneDrive, or Facebook, whatever. And then experts can analyze this data. So this is a big project that we are working, and 3-4 universities are involved in that. But my portion here is the chip, making of an efficient sensing chip. So in this direction, we explored magnetoplasmonic based approach. Over there, we have a very efficient sensing chip, which is based on gold nanoparticles immobilized on a system which is magnetically very responsive. And we have demonstrated this for Zika virus, and now we are doing it for this coronavirus protein. We have selected antibodies very smartly with the discussion of experts, and we were able to detect even sub-picomolar amount of the virus in a very less time. In a very, very less time, we were able to do that. And this research was published in Biosensors and Bioelectronics. This is one of the best journal of sensing technology. And at the same time, it was also very important that we explore different routes to detect coronavirus. So first approach was magnetoplasmonic, but I have a very good collaboration with Dr. N.Y. Kim, and he has a very brilliant PhD student, Prashant Sharma. He is really a very good young scientist. He developed a capacitance-based sensor that can detect coronavirus at a very low concentration. And the beauty of this sensing chip is that this is very robust. This is temperature-wise very stable, and it's not a complicated process. And using a very simple approach, of course, fabrication has a lot of engineering, material science, and surface science. But at the last, you just need to spit on this chip, and within few minutes, you have your data in your computer screen or on the cell phone screen. So we did a very systematic study, and every step of the fabrication is well characterized using microscopic techniques like atomic force microscopy and scanning electron microscopy. We did all type of functional assessment based on FTIR, which is Fourier transform infrared spectroscopy, to confirm that different bindings are taking place or every step is well justified. We detected coronavirus efficiently, even better than the system reported in the literature. This research is making noises in companies, and my collaborator got a very big project from a company in South Korea, and now we are working on making the final device that can be useful. And these devices are very useful. Look at this new strain of coronavirus, Omicron. Yesterday, we have 6 lakhs COVID patient in America. Means they 6 lakhs were tested. So we need yesterday 6 lakh systems to detect. And this is not only one time, they have to be tested often. So imagine the volume of testing chip we need with reference to the global demand. It's millions of chips every day. And the overall approach is still the same. Let's make efficient sensing chip, should be operated by a very tiny potential state and must be operated by a cell phone, so that we can not only detect the coronavirus, we can manage this disease management very smartly and very intelligently. Dr. Hardik is one of my very good collaborator at University of Houston. He's helping us in exploring artificial intelligence and Internet of Things to have this combo at last for intelligent health wellness. So based on this, my new book is coming, which is exploring different biosensing strategies of COVID-19 management. And this book is coming with one of my very best collaborator, Dr. Khan, who is scientist in CSIR lab, Bhopal. And the sensing prototype we have developed so far, now we are testing them using real samples with the help of some hospitals, local hospitals, and we will see that how efficient are they if it comes to the real world applications. And I'm very much blessed to have very good people around me. I'm very much thankful to my student and my collaborators, my team members, my institution, and some funding I have from company and federal agencies. And oh, I think I pressed something else. By the way, I'm done.
Thank you. Thank you, Professor Kaushik.
Yeah, I pressed something else and then
Talk. And now I'd like to invite Dr. Vikram Jena to carry forward the session.
Thank you so much, sir, for your wonderful deliberation. And I would love to congratulate first for your Young Scientist Award and also your research formalities which you have conducted and done so well in terms of WHO website related to pandemic and this disease, which is most affected by this world disorder, and very holistic approach adopted by you through your research for the mankind and for the generation still to come. And you nicely spoke related to 50 minutes about this pandemic corona and these biomolecular activities related to medicine or medical practice in modern world, related to equipments and nanomaterials, how to use in perfect direction in particular new generations and these medical modern medical equipments practitioners. At the outset, I would like to just need some light on this aspect. Rather, you are a environmental engineering or a public health expert, or more even a very nanomaterial user. I would like to know something specific. What is your idea in terms of our indigenous health practice, which adopted so many centuries ago by the Indian context or the Vedic age particular? And do you feel the changing scenario of this contemporary world, what you talked about, the Brazilian effect of 2014, rather you can take an example of the Spanish virus of 1919 and then 2020, the pandemic is concerned. How you relate and how you locate through your research, particular this time of very panic world in terms of the digital world, you can say rightly.
I think I don't feel myself qualified to comment on this comment because I'm a very young guy and I have a very well-defined area to focus. But I would say we need to have a balance. If I'm projecting natural remedies as a part of COVID-19, but most of the people don't know what are these remedies. So it has to be the part of our education policy, like how much we have to be dependent on modern science and how much we have to project natural resources importance as a part of social. I don't know how to say. My point is that if we need to manage something at the large scale, we have to have similar type of preparations. Right now, world is doing great. This pandemic is serious. we are making new vaccines, we are making new systems, and that's why we are able to at least know what is happening and at least able to tell people what is important. But at some point, there are many reports which are saying that natural remedies are capable to control this virus. And this is true, which has been seen in the first wave of virus in India, and even second wave of virus in India. Being so populated country, our death rate is very, very less compared to Europe and USA, where they claim to have a better nutrition and better medical facility. So better nutrition and better facility look good together, but they are two different things. So our Indian dietary system is different, which is more efficient to fight against these viruses. But if we see that, if I compare my knowledge of food with reference to the knowledge of my grandfather about the food, is totally different. I'm not so educated as my grandfather was. So I believe that this should be the part of education. We tell people about the about our natural resources, their value in, in health, which is very important. I think this is my opinion about it.
Thank you. Thank you so much, sir. And I would little bit add something more information to our global audiences, those are watching in YouTube and Facebook, in terms of this LPG is concerned, the lifestyle of people. Right, you rightly mentioned about your grandfather and you. What is the similarity between these food habits and lifestyle is concerned? When the new marketing policy is concerned, introduced in the new planet is concerned, the natural resources always devastating because we don't try to track the nature. The nature is one
Yeah.
of the most important and holistic part of our life. If you look back, the modernity is concerned, rapid industrialization is one of the most significant part of it. Oh, everyday life, we are going to facing a lot of challenges to track this report. You rightly mentioned about in your presentation, the tracking system of these COVID patients. The government is doing fabulous job in terms of your presentation. You are sitting at USA, Florida, and one of the most important university you are working in particular this time of this panic world. And in terms, you rightly mentioned in your first part of your presentation, you are a very village guy. How you assume? What is your hypothesis related to the Indian system is concerned? We don't have medicals, as we have 140 crores of people registered yet.
Mm-hmm.
And the pandemic is concerned, this big population. How you assume and what is your hypothesis related to your research? How could you narrate a very holistic approach in terms of these medical practitioners, these policymakers, these politicians, and last but not least, the health workers, those who are working around in 24 into 7? What is your opinion about it, sir?
My opinion, like in multiple aspects, like you mentioned a lot of things. And again, I feel that I'm not qualified to comment on everything. In terms of education, as I mentioned before, our education should be value added knowledge. If this class, after graduating from universities, will go to the community, and definitely after a few years down the road, they will be mentors of somebody. So this is a slow process to change the mentality of newcomers, and then they will come up as a different world. Now, with reference to our Indian health system, at the same time, I don't want to criticize, because every year we are growing in terms of population, and also we are growing in terms of establishment. I think every state, I don't want to look like racist here, but even state that has less resources is having more and more medical setup. So it's a gradual process. Every government is working in this direction. Sometime, whether they like or not, they have to work to look better in terms of world. And our medical system is better I would say, best. They did not think about their own life. They helped people in pandemic. Many compromised family functions. Many sacrificed their life. I know many of them. But I feel sorry when they are not treated well. They are hero today, but tomorrow people say he's corrupt doctor, he's making money. It's not bad to make money, but look at their life. They don't have any life. They don't have sentiments. They are robots. They have to operate brain without considering connections with the patient. It's not easy to even comment. It's a different world. And yes, government should take care of patient and government should take care of doctors. Our doctors in India, in majority, are not in good shape. They are not getting their salary on time. Yes, some are rich. Rich doctors are there too. Private practices are there. And yes, rules and regulations are not followed by hospitals. I'm not feeling comfortable to comment on government hospitals. They're doing better than their capacity because maybe they have more sentiments, but they're less in numbers. And I think overall improvement is required in every direction.
Thank you, sir. Thank you so much. Without wasting much time of yours, because your time is full, I know.
It's okay. I just started my day. I'm more worried about you guys. It's evening. You must be hungry.
No, not at all, sir. We are listening you. It's really passionate. When you are a background of environmental engineering and you working on these very sensitive biomedical practices, it's really wonderful and beautiful. Sir, what is your assumptions?
Say again?
Yeah. What is your assumptions about artificial intelligence is concerned? In particular,
I would say, let me ask a question. Who is your favorite superhero? Superman, He-Man, Mowgli?
Sir, you rightly mentioned the Mowgli Jungle Book, right, sir?
Yes. So, you know, he was created by a computer.
Right, sir.
There's no real Mowgli. I am the Mowgli.
I am also, sir.
But I never lived with the animals. So this is artificial intelligence. It's prediction. It can predict anything. And the artificial intelligence helping a lot. Imagine driverless cars, driverless satellites. We are seeing that change. Smartphone became very smart. Why? Because of technology. And who predicted that? AI. So AI is telling us what are the best possible ways to do something. First, second, if I know this work can be done by 100 ways, then I can figure out of 100 how many will work efficiently. That also can be done with AI. It's a different world and it's progressing exponentially. Quantum sensing, people are talking about quantum sensing, and some countries has institution of quantum physics, but there is no quantum. It's only in the book. I never seen any quantum. I can see nano by microscope, but I cannot see quantum. But this is happening. So America is investing billions to work on quantum physics, quantum materials. These right now, these are based on AI, and AI is gonna change world soon.
Thank you so much, sir. Thank you so much. Now I'd like to request Rudranan to go for the formal vote of thanks. Thank you so much, sir. All the way you're connecting from Florida, USA, and looking forward for future engagement also, sir. Thank you so much.
You're very welcome.
Thank you, sir. It is a wonderful to listening you, and we are humanities peoples, and trying to understand what are your research and specifically your expertise in analytical science and electrochemistry and nanotechnology. gas biosensors. So, before going to vote of thanks, I would like to ask just few short questions how we have to promote these research activities, and what is generally what is the basic concepts of chemistry in our rural areas, and what should be our teachers, those are in the stream of science, how they do good in specifically in the degree level students, and what should be your suggestions to develop the Indian education system, specifically in the sector of science,
Yeah,
in rural colleges?
I would say it's very simple. We have to work on teachers.
Yeah.
We have to work on teachers. If they are doing chemistry experiment in the lab, started in class 10th, we have to tell why we are doing it. We have to feed student in 10th standard that if you know this well, this is going to help you in future to achieve this goal. If I am teaching a chapter in my class, I should tell student why I am teaching it. No matter we are making a satellite or we are making a sensor, science came from 10th standard. So we have to make that bridge. You have to tell student, if you are paying attention today, one day you will be an entrepreneur. One day you will be Dr. Kalam. If you understand physics, you can make missile. If you understand chemistry, you can make bomb. So, and both are important for national security. So,
sir, what kind of differences you find in the schools of United States and India?
Approach is different. Here, approach is applied. Chemistry is same. But here we tell to the student, if you want to know solar technology, better you understand photoelectric effect.
Sir, another question is, what kind of research is done in India on a specific topic that you are researching specifically on biosensors? And what is
there is no difference. There is no difference. There is no difference. I know many people, many friends who are doing better than me in India.
Yeah.
So maybe they need different promotions.
Yeah. Thank you, sir.
Yes.
So on behalf of CARD, I take this opportunity to propose the vote of thanks. Those who have directly and indirectly contributed to World Human Sciences and Management Conference. At the outset, I would like to thank our guest speaker for today evening, Professor Dr. Ajeet Koushik. We are really enlightened with your deliverance, sir. We're thankful our coordinating institutions, Indian Institute of Management, Central University of Odisha, and Ravenshaw University for their support and guidance to organize this virtual event. I would like to thank Professor Sanjay Naik, Professor Satkumar Palita, Professor Mahadev Jaiswal, Dr. Vikram Jena for their continuous effort to promoting education worldwide. And I would like to thank our conveners, Professor Chandi Prasad Nanda and Charudat Panigrahi for their motivation and guidance. Especially thanks to our organizing committee members, Professor Srinivasulu NS, Dr. Sudarshan Mishra, Professor Loknath Mishra, Professor B.C. Das, Professor Saban Bag, Dr. Nupur Patnaik, Dr. Amulya Acharya, Shubham Das, Chinmay Sahu, Dr. Kamal Prasad Mohanty, Dr. Samuel Lima, Dr. Neha Sharma, and their unflinching support and coordination to organize this event. Our heartfelt thanks to all our academicians, research scholars, and students.
Let me tell you one more difference.
Yeah, please.
You speak around 50 names, but there are only 10 people.
Yeah.
You should not speak their name who are not here.
Okay, sir. Thank you.
We don't do this here.
Okay, sir. So thank you all for watching us in those who are watching us in Facebook and YouTube. And with these warm notes, I would like to thank everyone for joining us. Thank you, Professor Kaushik,
Thank you.
for your wonderful deliverance, and your smile is speechless. Thank you.
Pleasure. Bye bye.
Bye, sir.